Okay, so now we'll try question number 2 of the first exercise. And the question says that show that any positive odd integer is in the form of 6q plus 1, 6q plus 3 or 6q plus y. Odd positive integers should be in this form. So we had done the Euclid's division algorithm, which states that a equal to bq plus r. Okay, so whenever we have these type of questions, always the statement should be according to Euclid's division algorithm, a equal to bq plus r. And we know that r is always greater than equal to 0 and less than b. Okay, so r greater than equal to 0 and less than b. So here a is bq plus r. Dividend is equal to divisor into quotient plus remainder. You already are aware of this. Remainder has to be greater than equal to 0 and less than b. Now in the question, you see the coefficient of q here is 6. So what we are going to do is assume the value of b as 6. So depending on the question, sometimes they will give you this as 4q plus 1 or 4q plus 3. Then the coefficient of q is 4. Then the value of b will become 4. So this is a variable. So depending on the question, you will have to change the value of b. At the moment I am taking 6 because the question is demanding that, because the format is in the form of 6q plus 1, 6q plus 3, 6q plus 5. So once we take the value of b as 6, we know that r is greater than equal to 0 and less than b, and the value of b is now 6. So what are the possible values of r? R can be 0, it can be 1, 2, 3, 4 or 5. Cannot be 6 because the remainder is always less than 6, that is less than the divisor. So we've got here 6 cases. So let's consider each case. If r is 0, then what happens? The value of a is going to be equal to 6q plus 0, or we can write it as 6q. And when the value of r is 1, the value of a will become 6q plus 1. When r is equal to 2, a will become 6q plus 2. When r is 3, then a will become 6q plus 3. And similarly, 6q plus 4 and 6q plus 5. Okay, so these are the possible cases. Now when we look at the first case, r is 0, this is 6q. Now we know that 6 into anything, that is multiple of 6, will always be even. So this is an even number. What about 6q plus 1? If 6q is even, when you add 1 to that, that becomes odd. 6q plus 2, this is even, and even number plus 2 will become even, and then this will become odd. Similarly, this is even and this is odd. So what is the question saying? The question says that we have to prove that the positive odd integers are in the form of 6q plus 1, 6q plus 3 and 6q plus 5. And if you notice our odd numbers, they are in that form. So answer will be that all positive odd integers are in the form of 6q plus 1, 6q plus 3 and 6q plus 5. Now in the exam, suppose they had asked you about even numbers, and then our answers would have become different. The even numbers would have become 6q, 6q plus 2 and 6q plus 4. Okay, so I hope you understood. There is also a solved example. You can try out that, and then I will explain to you the next question.